We have a couple of examples here with terms just to quickly wrap up our introduction to polynomials. So we're going to sketch the graph of the polynomials if possible. So if it's not possible, we're going to state that and we're going to think about why. Looking at number 1, we want a reflected cubic, so some sort of negative x to the third with no terms. So if I think about negative x to the third, my end behavior is going to have to be up, down. So up, let me draw that just a little more sideways. There we go, up and down. Now I need to think, is it possible to have 0 turns? So if I think about degree 3, the number of turns it could have, maximum number of turns, is 2, which is 1 less than degree 3, or it could go down by any even, so 2 or 0. So it is possible to have 0 turns. And what 0 turns looks like is actually a lot like the parent graph. It has just a point of inflection and goes down like that. Doesn't have any sort of local maxes or mins. Number 2, reflected quartic. Quartic is degree 4. So if it's a reflected quartic, it's going to be down, down. Reflected even means it's both the same, in this case down. And 3 turns. So if I have degree 4, the number of turns I could have maximum is 3, or I could have 1, going down by the odd numbers there. So that is possible to have 3 turns with a degree 4. So I come up and I just give myself 3 turns, which means 3 maxes or mins. So there's my reflected quartic with 3 turns. Degree 6 polynomial with 3 turns. See if that's possible. First of all, degree 6 would be even, so they're both pointing the same way. In this case, up, up. And if I have degree 6, the most turns I could have is 5, or I could have 3, or I could have 1. So it is possible to have 3 turns on a degree 6. So he's up, up, and I need to turn 1, 2, and 3 times. Meet up with my end behavior. And there are 3 maxes or mins. Reflected degree 9 with 5 turns. So reflected degree 9 would be end behavior of up, down. There's my end behavior. Because it's odd, they're opposite. If I had degree 9, the maximum number of turns would be 8, or 6, or 4, or 2, or 0. 5's not on my list. I can't have an odd number of turns with an odd degree polynomial. So I'm going to say that this is not possible. Looking at my graphs down here, I'm going to go backwards. I have the graph of a polynomial, and I want to say if they are odd or even degree, and then what that minimum degree could be. So if I look at the first one, I know that he's going to be an even degree polynomial because of my end behavior, down, down. And then to state the minimum degree, I have to find my number of turns. So I have 3 turns. So that means I have a minimum degree of, it has to be 1 more than the turns, so it'd be 4. So that's a minimum 4th degree polynomial. Now it could be 4th degree, 6th degree, 8th degree, it doesn't matter. Any sort of even degree 4 or above is what that polynomial is. But it could not be a quadratic. Can't be a quadratic. Part B, I know it's going to be an odd degree because of the end behavior. They're opposite. If I count up my turns, I have 1, 2, 3, 4, 5, 6 turns. 6 turns means that I have a minimum degree of 7. This has to be a 7th degree polynomial or higher. Could be 9th, could be 11th, etc., but it could not be a 5th degree or it could not be a cubic with that number of turns. So there's a couple quick examples of how the turns and the end behavior fit together.